All right, guys, we're going to talk briefly today about systems of linear inequalities. We talked about linear inequalities last week where we're drawing the line, dotted or shaded, shade above or shade below. Now we've got a system of linear inequalities. That just means two or more of them. We're still going to shade. Now I mentioned here, I put the word in there, linear inequalities. But any inequalities you run into going forward, quadratic inequalities, whatever inequalities you're doing as you go through the rest of your math career, same principle holds. So we start with linear inequalities, same thing for everything. All right, we remember when we had these compound inequalities, we called them back in the fall, two or more inequalities at the same time, and we kind of look at the overlap of these two different regions and see what the final solution set is. So remember we had something like x is greater than or equal to 3 and x is less than 7. That was an closed circle arrow to the right and an open circle arrow to the left. And we looked for the solution set, the solution that belonged to, that satisfied both of those inequalities, we said was in the overlap of those two regions with an and statement. And we'll consider any of these systems of inequalities to be an and statement. The overlap would only be from here to here. So our final solution set was any number in between 3 and 7 would be a solution to that inequality, not including 7, but including the 3. So the number 4 is both greater than 3 and less than 7. The number 6 is both greater than or equal to 3 and less than 7. Anything in that overlapped region was the solution set. We have the same idea here. When we have more than one linear inequality, we're going to graph both of those things on the same coordinate plane and look for where their solution sets overlap. Okay, so this is pretty easy. So here are those two equations or inequalities I had on the last screen. Let's graph them both. Now I always get certain students who say, is it okay if we use multicolored highlighters to solve these inequalities? Yes, if you are neat and meticulous, go right ahead. However, if you are a sloppy inequality writer like myself, that is fine as well. So we're going to graph them one at a time, graph them in shade. And then what will happen is I should be able to tell by glancing at your graph if you have the right final solution set. So first inequality, y is less than or equal to x plus 2. So y-intercept of 2, we have a slope of 1. The fact that it's less than or equal to tells me that I need a solid line. Oops, so solid line goes this way. It's less than or equal to, which tells me I'm going to be shading below that line. I'm going to use the highlighter tool here just because I get a thicker line, but again, some of you will be neat and meticulous and use multicolors. I never have two colored highlighters with me, but I do on my iPad. So less than or equal to that line goes that way. The other line says y is greater than or equal to, y is greater than negative 1/3 x plus 4. So here's 4, here's 4. Sorry, playing with my pens here. Down 1 over 3. It's a negative slope, so I'm going this way. Up 1 over 3. This one should be a dotted line because it's strictly greater than. And now when I'm shading this one, I'm shading above that line. Now that's not my final answer though. The final answer for these problems is the overlapped region. So what I should be able to do is if you were sitting in the back of the classroom and I asked you to hold up your paper, I should be able to see very clearly that your final overlapped region is where these two things intersect each other. So here. Now again, if you are sloppy, I don't care. I can't promise you your Algebra 2 teacher won't care. I'm a sloppy writer myself. But if you mess up, it's okay for me if you, in your final solution set, write SS for solution set. If you are working in I don't know why you would do this, but writing your math in pen and you realize later that you drew a solid line, you meant it to be dotted, I'm okay if you say dotted. Okay, best idea here is light pencil, darker pencil for the final solution set. But if you mess up, I don't care. If you want to be neat, great. If you're not a neat person like myself, that's okay. Let's just try a couple more of these. Let's see. X greater than or equal to negative 3, y less than 2. So we have to remember which is which here. Well, let's see. X is less than or equal, greater than or equal to negative 3. All of the x's are negative 3. That means I go to negative 3 on the x, and every single x value will be at the negative 3. Greater than or equal to negative 3 means I'm going to be shading. I always say above or below except for these vertical lines, but this makes sense, right? Greater than negative 3. All of the x values towards this half plane, this side of the graph, would be greater than or equal to negative 3. Y is less than 2. Again, takes me to a horizontal line. Horizontal dotted or dashed line would be here. Shading would be below. Y is less than that line. But again, I should be able to tell your final solution set, your final shaded region, would be down here. Okay, so shade lightly, make it clear what your final solution set is. Remember what that means. It means that every single point in this final shaded region satisfies both of those inequalities at the same time. So if I pick any point in here, like, I can't even read what that is, 1, 1, the x is greater than negative 3 and the y is less than 2. The point negative 2, negative 3. The x is greater than negative 3, the y is less than 2. If I picked a point up here, like 1, 4, the x value satisfies the first inequality, but it doesn't satisfy the second inequality. So that's what we're looking for, is points that satisfy both of those inequalities at the same time. Remember, sometimes we need to put these things into slope-intercept form before we graph them. And again, I put this inequality in here as a reminder of what happens with the first one. So let's say negative y would be greater than negative 2x plus 4. We then need to divide by that negative 1 and flip the inequality sign because we divided by the negative 2x minus 4. So y is started off its life looking like it was greater than. Turns out it's a less than. So 2x minus 4. This is a dotted line. And then y is less than. So less than would be below that line. That's here. The other one, I'd subtract the x, 2y less than negative x plus 4, and divide by the 2. So y is less than negative 1/2 x plus 2. 2, 2, down 1 over 2. This one is also a dotted line. This one will be shading below. And again, the final solution set would be where they overlap. And the overlapped region here would be right here. Okay, so remember, multiply, divide by a negative, flip the inequality. Couple interesting things here. What happens, what do we notice about these? X plus 3y, x plus 3y. What's going to happen as we solve for the y? Well, let's find out. So for that first inequality, I would subtract the x, 3y greater than or equal to negative x plus 6, divide by that 3. So y greater than or equal to negative 1/3 x plus 2. What's the other one going to look like? Well, I'll do the same thing, right? Subtract the x, divide by the 3. I'm going to end up with y is less than or equal to negative 1/3 x plus 4. So interesting thing here, I have two parallel lines. So with parallel lines, a bunch of things could happen. Let's see what happens in this case. So positive 2 down 1 over 3. This is a solid line. And greater than or equal to means I'm shading above that line. The other one, y-intercept is 4, same slope. Down 1 over 3, sorry. Also a solid line. In this case, y is less than or equal to, so I'm shading underneath that line. And we can see here the final solution set is the region between those two parallel lines. So with parallel lines, we have a bunch of things that could happen. The overlap could be between those two lines. There could be no overlap at all. If one of them went up and one of them went down, one of them was up here, one of them was down here, there is no overlap. That's a no solution. It's also possible that the inequalities go the same direction. Let's look at 2 of those and then we're done. So let's say we have y less than 1/2 x and y less than or equal to 1/2 x minus 3. So y less than 1/2 x, y-intercept of 0, up 1 over 2, up 1 over 2. This is a dotted line. Y is less than means I will be shading below. The other one, y less than or equal to 1/2 x minus 3. We have, again, a slope of 1/2. This one is a solid line. And now we're also shading below. So the overlapped region here is actually below that second line. This would be my final solution set. Sometimes that happens. It's no big deal. Just follow along these parallel lines. We have to do the work to figure out where the overlap is. If those were both facing the other direction, the overlapped region would be up here. So no big deal, just work them out and see what happens. And I think we'll stop there. We'll look at some special cases tomorrow in Zoom. Check the PDF, just practice these. They're not a huge issue. We're going to keep it real simple. And that's it. Have a great day, guys. Bye-bye.